Problem number 10. We're already given the factored form of f prime, so we can quickly use our first derivative test to figure out where we might have any maxes and mins. So we can see that f prime is a polynomial, so therefore f of x be a polynomial as well. Picking a test value to the left of -2, let's pick -3, let's say. Anything to the second power is going to be positive, and then -3 minus 3, that's a negative. So on the interval from -infinity to -2, we can see that f prime is negative. And then in between -2 and 3, let's pick 0. Okay, same thing. First factor is going to be positive. Second factor is 0 minus 3 is going to be a negative. So positive times a negative is a negative. Okay, and then any test value greater than 3, we can see that last factor is going to be positive. And so first and second factors are both positive, and so therefore we have that f prime is positive on the interval from 3 to infinity. Okay, so the behavior then of f of x would be that f of x is decreasing, and then decreasing, and then increasing. Okay, and so therefore we have a local maximum nowhere. There is no local maximum, because keep in mind this is a polynomial function. F of x is going to look like this: down, horizontal tangent line, down, and then up. So our only extreme value is going to occur right down here at that second critical point right there. That's going to be our minimum value. Okay, our local maximum then, if we're going to fill in our blanks here, is none. We have no local maximum. And then we do have a local minimum at the x value of 3. Okay, at x equals 3, because that's all it was asking. It's asking for the x value, or the x coordinate of where we had our mins and our max values. So then if we want to find any points of inflection, we have to find our second derivative. So it's kind of a bummer that we've got to differentiate this function here, because it's factored and it's got a second power, so we have a third degree polynomial. I'm kind of not wanting to do this, but nevertheless I made you do it, so I might as well do it as well, right? Alright, so let's go ahead. So f prime, I'm going to keep it factored. F double prime is equal to, we have the first, x plus 2 squared, times the derivative of the second, that would be a 1, okay, plus the second, which is x minus 3, times the derivative of the first. So the derivative of the first is 2 times the inside, x plus 2 to the first power. Okay, and then multiplied by the derivative of x plus 2, well, that's just 1. So we can clean this up a little bit, and this is the hard part. You know, it's harder to see that you can actually factor out an x plus 2. So I'm going to do that. I'm going to factor out an x plus 2, and what am I left with? Well, my first term has an x plus 2 squared in it, so I still have an x plus 2. And then my next term, I've already factored out that x plus 2, so I have a plus 2 times x minus 3. Okay. Well, I can clean that up a little bit, and we get x plus 2. And then let's see if we can do all this in our head. X plus 2x, that's 3x. 2 minus 6, that's minus 4. Okay, so f double prime is equal to 0 when x is equal to, that's f double prime. Let's do this. So f double prime is equal to 0 when x is equal to -2 and when x is equal to 4 over 3. Okay, so 4/3 and -2. Well, we need an f double prime chart, or we need to do the f double prime test. -2 and 4/3. Alright, so to the left of -2, you can see we have an inflection point. Hopefully we can see that, knowing what we know about our polynomial function here. We know it's a 4th degree polynomial because f prime is a 3rd degree. And we already talked about this, that we have our f is decreasing, and then f is decreasing again, and that happens when we have a critical point right there. But then also that's an inflection point. Okay, So it's going to be an inflection point at x equals -2, but let's confirm that. So when we pick, let's say, -5, we can see that f double prime is negative times a negative, so we have positive. Therefore, f is concave up on that interval, which we already knew. And then -2 to 4/3, let's pick 0 is a good one. We have a positive times a negative, so therefore, on the interval from -2 to 4/3, f double prime is negative. And then to the right of 4/3, we can see both of our factors of f double prime are positive. Therefore, f then is concave up, then concave down, then concave up. Therefore, our two inflection points occur when x is equal to -2, and also, though, when x is equal to 4/3. Okay, so there we have our two values for x when we have inflection points for f. Alright, so let's try number 11 here. We're only at the 6-minute mark. What is the minimum value that f of x attains? Okay, well, we know if we want to find a minimum value that we have to find a derivative. And oh boy, we get to find the derivative of a ln. That's not so bad. First times the derivative of the second plus the second ln of x times the derivative of the first, and the derivative of x is 1. And what is the minimum value? Well, okay. We can see that the domain, let's try the domain first. The domain is all real numbers greater than 0. Okay, so we don't want to consider any x values to the left of 0. We don't even want to consider 0. Okay, so we want to find when f prime is equal to 0. Okay, and f prime is equal to 0 when, notice we can cancel these x's here, so what we really have is 1 plus ln of x. Let me write that here, 1 plus ln of x, so there's no confusion. That's what f prime is equal to. So f prime is equal to 0 when 1 plus the ln of x is equal to 0. In other words, when the ln of x is equal to -1. Okay. Well, when is the ln of x equal to -1? What is x? Well, this goes back to your pre-calc honors skills. Can you solve a logarithmic equation? And you should quickly see that when e to the -1 is equal to x, that's rewriting this equation in exponential form. So these two equations, just a quick review on logs and exponential functions, when you have an equation that's and your variable you're trying to solve for is locked up in the log, convert to exponential, and vice versa. If you're having trouble solving the equation, it's in exponential form, convert it to log form, and then we have our value. We have our x value of e to the -1, and that's 1 over e. And so we're not being asked, though, what is the x value, what's the input. The value, though, that's the output. Okay, that's our output. So we need to figure out what f of 1 over e is equal to. But if you wanted to confirm that by an f prime test, we can do that. 1 over e, that's about 1/2, let's say, or maybe 1/3. So let's pick 1/8 in there. So I think I've been doing my my f prime tests not in red, so let me be consistent with that. Okay, so f prime test, we have 1 over e, which is about, it's between 1/2 and 1/3, so let's just say 1/3 on the low side. 0, to the left of 0, this function doesn't even exist anyway, so you don't need to worry about anything like that. And anything to the right of 1 over e, no more critical points. So hopefully at that 1 over e value we're going to find a minimum value, because otherwise it's decreasing. So if I'm kind of shooting all around here, if f is decreasing and then f is increasing, then certainly 1 over e would be where f of x would attain its minimum value, because it would never reach a lower value, never come back down, otherwise we'd have another critical point. So that being said, let's just make sure. I'm pretty confident that's where it's going to be. Let's pick 1 over 5, let's say. 1 over 5, 1/5 times the ln of 1/5, that's negative, because ln of 1/5 is negative. Alright, so we have negative. And you should know that ln of 1/5 is negative. You should know the shape of ln of x. And you should know that anything between, any input between 0 and 1, And if I draw the graph of ln of x, here's the graph, there's ln of x, and there's 1. So on the interval here from 0 to 1, we know that that the ln of x is negative. This is all negative stuff here. Okay, that's less than 0. So the value of the function is negative when the function's graph is below the x-axis. So anyway, to the right of, let's see, what are we doing here? 1 plus, oh, what did I do here? 1 plus ln of x, so f prime is 1 plus ln of x. Oh yeah, let me see here, hold on. 1/5, that would mean that ln of x was equal to, that'd be kind of hard to tell, wouldn't it? Well, I guess you'd maybe need a calculator for this. No, there's a way to do it. You could do it in a different way. Let's pick 1 over e. Let's pick a better value than 1/5. Okay, sorry. Let's pick a value like 1 over e to the second power. How about that? 1 over e to the second. 1 over e squared. Okay, so when you replace x with 1 over e squared, that's e to the negative 2. So then this guy, ln of e to the negative 2, would be negative 2. Okay, so 1 minus 2 would certainly be negative, and so that would be a better way. So you don't need a calculator, you could just pick a better x value than I picked of 1/5. Okay, so anyway, to the right of 1 over e, we can pick e, and ln of e is 1, and 1 plus 1 is 2. So we do have positive, positive there. And we want to find the minimum value. So, sorry, it's getting a little late here. The minimum value is, therefore, f of 1 over e, let's put e to the negative 1, is e to the negative 1 multiplied by ln of e to the negative 1, which is negative 1. So there's our minimum value, negative 1 over e. And if you wanted to write it like that, that would be fine. Equals negative 1 over e. That is our minimum value of this function. That's tricky. Good to know, but still tricky.